Hello, I'm a member of the BlueSky team here at EIA, and today I'm going to discuss how we've thought about representing time within a BlueSky framework. As you're probably aware, the goal of the BlueSky prototype is to model the future interactions of the energy economy across multiple decades. The challenge that we face is representing every second across the next 30 years within a model is an intractable problem to solve. So, we need to make simplifying decisions on how to represent that longer time horizon within our model. Here, I have the prototype open using Visual Studio Code. We'll navigate to SRC, Source Integrator Input, where we have stored our temporally related input files. We've decided to create a system of files that allows users to flexibly select groups of hours, days, and years within the modeling framework. The first file I'll show you is CW hour, which assigns hours within a day to different groups. In the file I have open here, the first column contains hours 1 through 24. The second column contains map hour, which then groups those 24 hours within a day into 4 separate groups. In addition to mapping hours within the day, we also map days within the year. The next file I'll show you is CWS day, which stands for Crosswalk Season and Day. Here, the file has a similar layout as before, but we start with an index of 1 through 365, which represents 365 days within a year. The next column over is map day, where we map the 365 days in the year into separate groups. In this example, we're mapping to 24 distinct groups. And then map S is mapping the 365 days to 4 seasons. In total, we have in our default temporal resolution, we have 4 representative hours for each day, 24 representative days for each year, for a total of 96 representative time segments per year. If you're interested in testing the model using different temporal resolutions, we've pre-configured a few alternative temporal resolutions in advance for you to try. To do this, you would edit the runconfig toml file, scroll down to SW temporal, and change default to one of our pre-configured options, such as D8 H12 or D4 H24. Or if you're so ambitious, you're welcome to build your own using the same file structure we just walked through, and then save your versions of the temporal resolution in the temporal mapping directory under the inputs, using your own custom naming convention, and then add that convention here. In addition to allowing for flexibility of temporal resolution within the year, we also set up the capability to allow for temporal flexibility across years. To edit that, you would go to the SW year file. Here you can see the default is set up to run for years 2025 and 2026, but you can just add a 1 to a particular year to add that year to the model solve. Beyond just running for those years, we also have a configuration settings here within the run config file called SW-ag years, which gives you the option to toggle between how you would represent the years between intervals. So if SW-ag years is set to 0, then each year selected in switch year has a weighting of 1. If you switch SW-ag years to 1, then the weighting of years is based on the interval between them. So in this example, year 2025 has a weighting of 3, 2026 has a weighting of 1, and 2030 has a weighting of 4. So to recap, I've discussed how we've considered the temporal resolution within our modeling framework in a way that accounts for hours, days, seasons, and years. We've set up this framework to be flexible so that modelers can choose the representation that best works for them. We'd appreciate any feedback on how we set up the temporal resolution or feedback on any other parts of the model. Don't forget to send your feedback to nextgenerationmodel@eia.com.